So, our first example with energy questions is this one. So, the man is jumping off a 10-meter high cliff into the water below, and I'm going to use energy to find his velocity. Now, I know I could do this using the kinematic equations, but I want to do this using energy instead. Now, the first thing I need to do is think about at the start, when he's up here at the top of the cliff, what kind of energy does he have? So, at the top, his energy, his total energy, is all due to one thing and one thing only. He's not moving yet, but he is off the ground. So he has gravitational energy at the top. And this I can find the value of because the gravitational energy equation is easy. I can just substitute it in. It's the mass of the object times gravity, the acceleration due to gravity times the height. So in this case, it is the 70-kilogram man times his 9.8, which is the acceleration due to gravity, times, in this case, the 10-meter high cliff. So this will tell me how much energy we're dealing with. Now remember, this will be his total energy because he only has one type in this case. So that means it will give you all of the energy involved. So put that in my calculator and I get. Now, energy numbers tend to be quite high. Don't worry about that. It's because they can be high, right? Each joule of energy is not a lot. So, joules. Remember, that's in joules because it's an energy. I want to now know his velocity as he hits the water. So as he hits the water, he's covered the whole 10-meter fall. He's fallen the 10 meters and now his height would be 0 at the bottom. So at the bottom his height's now 0, which means he has no gravitational energy anymore. He only now has kinetic. His total energy is only due to kinetic. Now, a lot of people will just say that his EG is equal to his EK. The reason I don't do this is because I want to think about this in total energy. When I get to more complex questions, I need to be able to deal with those more complex questions where there's more than one kind of energy. So I don't want to just make EG equal EK. I want to actually think of it in total energy in terms of that. So I know his total energy. It's right here. His total energy is 6,860. That's how many joules of energy he had. 1/2 times his mass, which was 70, and then his velocity squared. Remember, I'm going to have to take the square root in order to find these answers. So I'm going to divide my half and my 70 over, and then I'm going to take the square root. So the square root of that is 14. So that means his velocity would be 14. But 14 what? I have to think about what units I'm going to use. Remember, the base units for velocity that went into this are meters per second. Joules are based on meters per second. So that's what my uh, units are going to be. All I need now is a therefore sentence. There we go. All done.